In this video, we're going to continue to talk about optimization. Let's take a look at this example. An open top box is to be made by cutting congruent squares of side length x from the corners of a 20 by 25 inch sheet of tin and bending up the size. So basically you have 25 inches by 20 inches sheet of tin. And what you're going to do is you're going to cut the corner, which are squares, and you're going to fold it so that this becomes an open box. Now he says, how large should the squares be to make the box hold as much as possible? So basically we want to find the maximum volume of this open box. So this whole thing, we want to find the value of x so that we could cut the corners of this rectangle so that the open box will have a maximum volume. And you know that the volume of a box is length times width times the height. So this is our primary, because we got to find the maximum volume. So we got to find the derivative of volume. But what is length? The length is going to be 25 minus 2x. What about the width? The width is going to be 20 minus 2x. And the height of this box is going to be x. So the volume of this box is going to be 25 minus 2x times 20 minus 2x times x. Now when you multiply all these out, you're going to get 4x cubed minus 90x squared plus 500x. So the derivative of the volume is going to be 12x squared minus 180x plus 500. And at this point, you need to find the critical point. So you have to set that equal to 0 and solve for x. Since the calculation is not so simple, you could either use a quadratic formula, or in this case, I'm going to use the graphing calculator to find the critical points. So what I did was I put the v prime as my y1, and I want to graph this. And before you do that, why don't you set your window from 0 to 25, because the largest x value can be is 25 and the smallest x value can be 0. So let's graph this. Again, this is a graph of v prime, the derivative of volume v. Now we have two critical points here. And notice, v prime changes from positive to negative at this value. And v prime changes from negative to positive at this value right here. Let's find both values. So second, trace for second calc. And you want to find 0, so press 2. The left bound. Left bound and press enter. And right bound, press enter and enter again. So the first 0 is going to be 3.6811869. And let's find the second 0. So second, trace, press 2. Let's move the left bound around. It's about 11.1. So enter. and the right bound. Press enter and enter again. So second zero is at 11.318813. So using the V prime, we have two critical numbers here, and V prime is positive over here, and B prime is negative on this interval, and V prime is positive on this interval. So as you can see, the maximum volume occurs when x equals 3.681, because that's when V prime changes from positive to negative. So x has to be approximately 3.681 in order to have a maximum volume. And what is the maximum value when x equals 3.681? Well, you got to plug it in and multiply L times W times H. And when you do that, the volume will come out to be approximately 820.528 inches cubed. Now let's take a look at our last example. It says you have been asked to design a 1 liter oil can shaped like a right circular cylinder. What dimensions will you use the least material? So you have a right circular cylinder. And this is the radius, R, and that is the height. And you know that the volume of a right circular cylinder is pi r squared times h. But notice, it says what dimensions will use the least material. So basically, we got to find the dimensions such that it will use the least material to cover this volume. And in order to do that, we need to find the surface area. How do you find the surface area? Well, let's open this up. You'll get a circle on the top, and you have a lateral area, and you have a circle on the bottom. So how do you, the area of two circles is 2 pi r squared. And the area of this rectangle will be, the length is same thing as the circumference of the circle. So it's going to be plus 2 pi r. That is the circumference of a circle, and that is just the h. So surface area is 2 pi r squared plus 2 pi r h. And this is our primary because we need to find the derivative of that so that we get the least material. But we got a problem. We have two variables, r and h. So in order to make it into one variable, check this out. It says 1 liter. Now 1 liter is the same thing as 1,000 centimeter cube. So the volume of this right circular cylinder is going to be 1,000 centimeter cube equals pi r squared h. So therefore, we could say that h is 1,000 over pi r squared. So instead of this h, we could substitute 1,000 pi r squared. Now let's simplify. You get 2 pi r squared plus pi cancels out. R will cancels out. So you get 2,000 over r. And we need to find the derivative of that to find the critical point. Now, what we're going to do is we're going to use our graphing calculator and graph the derivative of this to find the critical point and which value gives the least material. So now you have equation of surface area, and I'm going to graph the derivative of surface area using the graphing calculator. So again, I deselected y once because I just want to see the graph of the derivative of the surface area. So let's graph it. And this is the value you get. And again, you might have to change the window to see, look at your graph. And you got to find the value of that. So we need to do second, trace, and choose number 2 for 0. Left bound. Press enter. The right bound, make sure your right bound is above or depending on where the x is, make sure it's right side of the value that you want to find. Press enter. And press enter again. And there is your 0. 5.4192608. Now, again, this is a derivative of s. So this is a graph of s prime. S prime is negative, and it changes to positive at x equals 5.41926. So indeed, this value gives you the minimum surface area. So using the S prime chart, you know that the surface is minimum when R is 5.4192608. So R is approximately 5.41926. And to find the H, by the way, it's a centimeter. And to find the H, all you got to do is plug in the R over here, since H equals 1,000 over pi r squared. And you will get approximately 10.839 centimeter. Now it turns out that if you multiply 2 to R, you will get the H. This right circular cylinder will have a dimension that will use the least material when H is equal to the diameter, which is 2R.